Hello friends of .NET, I'm Imo Landworth and you can find me on Twitter at TerraJobs. So this is our 15th episode where we build a compiler from scratch. And in today's episode we're going to implement our actual compiler project, meaning a console application that takes in a bunch of paths and then we'll actually run the program, or I think technically compiling the program, but we're not quite there yet for compiling the program. So we will start with just interpreting the program that we passed to the compiler. So I have a quick demo here where you can see what the end result will look like. So we will have files that we can edit just in VS Code. We register a shortcut that will just evaluate our program. And then also, of course, when we have errors, we report those back so we get squiggles in VS Code. If you've never done that, it's actually quite easy to set up and doesn't actually require a lot of magic. So that is what I want to focus on today. Then I think it's time for me to just read the comments really quick, because since the stream started, there's already a bunch of comments in there. Yes, it has been a while since the last time. I think it's roughly a year ago that I streamed last time, so it is time. So God Basic is asking, first time participating in live, which is awesome. We'll have to watch the rerun, continue the Visual Basic version of this. That is awesome. So if you are inspired by this series and you want to write your own compiler in a different language or just for a different language, that's totally cool. And if you do that, please let me know, because I'd love retweeting you. I'd love taking a look at your code and just also watching videos, because it turns out I like watching videos where people write compilers for some reason. All right, so then let's just jump into the other side of it. So before we do anything crazy, I think it's time for me again to take a look at the pull requests, because a good chunk of them have been flowing in since last time. So the last two bottom ones here, local functions and try catch statements, are still in the same state that was last time in. But basically the idea is that before we add any of those, I want to get a little bit more, I guess, certain with the compiler project itself, and making sure that when we actually emit code that I don't complicate my life too much. But I still want to take them eventually because they are cool. Same with the optimizer, so that's also something I need to take a look at later. So let's just start with these ones here. They look pretty straightforward. So fix an exception when function name is empty. That's an interesting one. So how is that possible? If the function name is empty, we should have reported an error. Okay, so this is all just testing, which is cool. Oh, I see. So the parser reported an error, but then the binder failed because we tried to look up a null text in the scope. That makes a lot of sense. That makes a ton of sense, actually. So that's something I should definitely take. All right, so with the other one, some minor changes. Escape backslashes in dot files. I found inconsistencies in the graph list docs in this regard, but dot won't display a backslash in the generated graph unless you escape it. Use an indented text writer by graph node labels, otherwise one would be created automatically for each label. You can use commas or semicolons to separate attributes in dot files, so use a comma. Fixed diagnostic message. Yeah, this is also cool here. So last time I was just lazy, I was just emitting them with a space, and now they're actually going as independent things, which is probably the right thing to do. So it does not look ugly. Yeah, that's the indented text writer. So we automatically create one, but we would create one per statement, or per node, I guess. Yeah, I mean, either way works. That looks good. Yeah, trailing comma. Yeah, we have apparently some issues with that. I mean, there's nothing wrong with that. There's a message here that looks better now, so it's all goodness. So let's take this as well. It's always funny when I type messages and I change my mind like 5 times over what I actually want to type. All right, so then this one, dun-dun-dun-dun. So let's open these guys as well. Gee, that's a lot of PRs. Better error messages from mismatched symbol types. So what is happening here? I see. So I think the difference here is, so logically when we do things like this where we assign, so ignore the brackets here, they're just used to match diagnostic spans back to the input file, but basically what it says is print equals 42, print is a function in our language, and so the error message we are getting is print is not a variable. And then in this case, foo, we invoke the function on foo, but foo doesn't actually exist. And now we declare a foo, so it's a variable, and now we try to invoke this, and now we get foo is not a function, which is better than function foo doesn't exist, so we at least know what's going on. And so yeah, this is the changed error message. Instead of saying print doesn't exist, we say print is not a function. And the way it's being done is, instead of saying bind variable, we say bind variable declaration. Identifier is only sure. I see. So there's a difference now between binding a variable declaration and binding a variable reference. That's fair. And then all of this code is deleted. Interesting. Where did that code go? Oh, I see. It's just expanded. Yeah, instead of having different overloads for variables and functions, we just have try lookup symbol. It returns a symbol because we have a single symbol table now. Yeah, that makes sense to me. So like that's generally goodness, because that means all the symbols live in the same symbol space, which is generally what you want as well. I guess in 15 episodes, I'm 15 episodes late to this project. Well, the good news is all the episodes are recorded, so you should definitely watch them all on YouTube. Actually, the whole transition magic here always has a URL in it, minsk-compiler.net, which just takes you to the playlist on YouTube. So you should be good to go. Fix control flow evaluation for empty functions. Yes, I did notice that as well. That is something I wanted to fix anyway, so that is good. So instead of crashing, we should just say not all code paths return a value. That makes sense. Yeah, I also removed the comma, which probably will now conflict. And then we say, instead of saying last, we say last.default, and then we just say if the last statement is not null. Yeah, that makes sense. So how is this not conflicted? Oh, because it's the exact same change? Fair enough. All right, fix backspace handle on Linux terminal. What? What does that mean? I think now it's time for coffee. I see. So instead of handling the backspace, it prints it back. So we're saying in handled key, if the key is larger than a space, I'm amazed because I think backspace, isn't backspace in ASCII like 8 or something? Because it seems a bit weird that this check here where we say larger than a space, I mean a space is what, 32 or whatever, ASCII? Shouldn't that be higher than backspace? I mean clearly somebody tested that. Not sure I fully understand it. But hey. That is the fun with multiple platforms. All right, so that one we did, this is the red. Fixed solution file name casing on task.json. Yes, we have not been very consistent about that. That is good. Good point. All right. Typo? No, I do not make typos. Yeah. Keep track of the original source tag that erased the diagnostic message. This fixes an exception in the REPL when trying to highlight the span location of a diagnostic message when a symbol is redefined that affects a previous declared function. Given the following sequence of inputs, let x equals true, function, blah, blah, blah. If at this point you enter let x equals high, the error message is displayed cannot convert string to bool. An explicit conversion exists missing a cast, followed by an argument exception. Yeah, this one makes sense because the way we print the diagnostic messages right now is we don't check when they span multiple lines. And that results in weirdness. Yeah, this one we will fix today anyways, because, so today the other reason, the other thing we're not doing is you're not tracking the text at all. Yeah, I think I've seen this PR. So basically what he is doing here is he passes in the source text, which is basically the buffer that we're parsing, and then passes that to the subsequent systems. And that is not what I want to do. So I guess it's a comment. That is a good issue, but I will fix this today in a different way. Sorry for that. All right. Always painful when I have to say no. All right, so now we have only the three complicated things left, and we don't want to tackle those today. Yes, the PR uses key char, not key. I got that, but I thought the check was for key char, and I guess maybe my mental model is wrong, but I kind of assume when you place a backspace that the key char would be ASCII 8. So that should just work. Maybe, maybe not. All right, so let's first do the usual. Let's just pull down what we just currently have merged. Then let's make sure we have a clean working copy. Let's restore. Well, let's build, but if we now have build breaks, I'd rather find this out now rather than in the middle of my stream. I see. So I guess we did not And we fixed the error message. We did not fix, where is that? It's evaluation test 640, no, isn't there? Yes, no, I guess that's not the one. It's evaluation test 482. Evaluation tests 482, right? Yeah, that was the one we wanted, is expected. Let's try this again. There is a downside of having too many tests when you find that every time you change your program in any way, that you then have to fix all your test cases again. So I guess we want to commit this and say, well, I guess we have some redundant spaces. Actually, now I'm curious. Yeah, whatever it is. Whatever it is, it's probably a trailing line space that we removed, hopefully not added. Fix, test, break. Let's just push this straight to master because we can. Yeah, there's one more thing. I guess at this point I should just create the episode branch, check out -b. If only I could type it. That would be episode 15. Yeah, I guess we can already do that. So there's one thing here that we have in our tree, which is we have this extensions thing here. But unfortunately, I don't know whether you noticed that every time you launch VS Code now, let's just show you what I mean. It okay, we update VS Code before we do that. But then also, once it comes up, we will get a prompt to install an extension that we don't have because the extension got renamed, so our suggestion no longer works. So here's the weird message. You probably not see this. All right, so now we're in the right thing again. So you can probably not see this here because we have because that's where my camera is. But basically, it says. Let me just pump this to the left here so you can actually see it. It says the below one extension workspace have recommendations because MS not found in marketplace. So we can just easily fix this by going to our plugins here. We have the C# extension here, and now it's called ms.NET Tool C#. So we just need to update the string here to point to the correct one. And now let's just commit this guy. Fix name of extension. And now we can go back to Minsk and just create a PR. Episode 15, so in case anybody wants to follow along for the ride, I will push incrementally as I make changes. All right, so far so good. So let me just cheat a little bit because I want to bring up my episode notes. I was about to say, if they're empty, I might be in trouble. But fortunately, they're not empty. All right, so what do we want to do now? So we already have things we want. So basically we have our interpreter project here, MI. And so MI is basically just our REPL, right? So if you just run our REPL right now, which is also a thing. So right now we have this run command that runs the REPL. I probably want to rename them to MI to just make it clear that they run the REPL rather than the compiler. I think this would probably be a good change. So if you just look at run MI here, it just runs the MI project after building it. So probably we should rename these guys here. So just rename them to MI. So let's do that. Let's rename run to MI. All right, so now I think it's time for us to create a secondary project, and probably what we want to say is go to src, and then in here we want to say .NET new console output name should be MC, I guess, for the compiler project. And then while we're here, we should also add it to our solution. So what is that? MC. All right, so now we have an MC project here, hopefully, which I'll consider what does the target, netcore app 3.1. Yeah, actually, why not? Why not? Let's update our project to, what is this targeting? Netcore app 2.1, so let's move this to 3.1 as well. Which now begs the question, what are we actually pulling down from Azure Pipeline? So you might actually build with the wrong thing. Well, that depends on what the build server has, I suppose. Let's see what happens. Let's see what happens. Let's just entertain ourselves for a little bit. Let's call this upgrade to .NET Core 3.1. This is the thing, what happens when you're not coding for like a year. All right, so now we have our compiler project. Our compiler project doesn't do anything right now. It prints hello world, which is probably not what we want either. So let's just do the following. Let's go in here. So we have our, no, not actually here, here. We have our MI commands. So now let's say, can I do this? Will this actually work? MC not star? Probably not, right? No, it does not. In that case, let's say copy MI to ms.cmd, yms. mccmd. And then let's say mi dot shell to mc dot shell. The one thing I'm not sure of is what I have to do to get the right bit flag set on the Windows side of the house. Hopefully the copying just did that, but it probably did not. So we may have to fix that later. All right, so now we have our compiler here that just runs the compiler, and we have the compiler project. So that's so far so nice, but we haven't done much yet. So now we need to add reference to our project here. So the easiest way to do this is just copying this reference here, which actually I want to go down here. And then once we have that, we should be able to new up our stuff. So the way this currently works, and we can probably steal this as well from our Minsk REPL. when we evaluate the submission, we just parse the text. Once we have the text, we create a new compilation and then send this there. So let's just copy this code over. So let's say first, if args length is 0, let's say console error out, right line. Usage is MC source path. Return. Let's say if args length is error, only one path supported right now. Return, and then we say var path is args single. Right, and then we say, okay, syntax tree parse. So first of all, what is the text? It would say var text is file read all text for path. And then we say, that would be text. Then we have a syntax tree. We create a compilation out of it. And then we just say compilation. What is it? I guess we have to run restore again for this to do anything meaningful. That's fine. Probably have to close this guy again. All right, Brett Wilson says git update index schmort plus x. Nice. I did not know this. All right, let's do that. So in our case, we already have it for mi because we just renamed the file. So we only need it for this guy. Well, it probably helps if I would be in the right folder. Well, I'm in the right folder. Oh, because the thing doesn't exist in the index yet. Okay, fine. Fine, be like that. Okay, we do this later. All right, now we should have a suggestion at least. Yes, okay, now this works, so we now know where stuff is actually coming from. Getting IntelliSense is a nice thing. All right, so yes, we need syntax as well. Evaluate. And then we just say new. Jesus. No, I do not want that. That would be kind of ridiculous. So how about let me add some usings for that instead. All right. So now we have the result. Now the only thing is, of course, you want to print the result back in case we have errors in the source input. But before we do that, let's just make this thing here somewhat sensible, because otherwise I will forget. So we call this Minsk. So the thing is, right now in our REPL, I think somewhere in here we have some sort of code that prints the diagnostics, which, as I said earlier, has some issues here when things are multiple lines and stuff, because we assume that the span itself is on the same line, which is probably not true, but for now that works for us. But the point is I don't want to repeat myself here. I want to just copy and paste this code over. So what I will probably do is extend our already existing Minsk IO helper stuff here, text writer extensions. Right now this guy is internal, so we just make that guy public. If you're watching this at home, don't try this at home. Like, it's generally a bad idea to have extension methods on types you don't own, and especially when they're as specialized and generic as this one here. It's a little bit weird to do that, but for all purposes, that's good enough. So what I will probably do is I will take this code here, our text writer extensions, or text span comparer. Interesting, yeah, the text span comparer will probably just move over there. So let's just take this stuff here. As it is, copy. And then in here, oopsie, we just say public static void write diagnostics for this text writer, and then we take an immutable array of diagnostic. Actually, we probably take an enumerable of diagnostics. Good enough. Probably need this guy. Yep, fair enough. And then we can just say for each var diagnostics in diagnostics. All right, we also need the syntax tree apparently for now, because that is just the way we do things. Syntax tree, which we don't want in the long run, but for now we have it. Then we just order this guy, which means I take all of this stuff here. Yeah, that's also one of those things that we should probably get rid of at some point. We should just make the text span itself comparable. That makes a lot more sense. Might as well seal it while we're at it. Delete this guy. Yeah, bye-bye. All right, so what is this guy complaining about? Okay, we need the diagnostic one. We need probably link. I mean, in fact, we can make our lives probably easier by just saying start, then by and then we can just get rid of the type entirely for now. Seems overly complicated for what it does. So we just sort this guy by some sensible thing and print it out to the console. All right, sweet. So now instead of doing this here in our REPL, we say console out right diagnostics. Comma syntax tree. And I hope, yeah, of course it doesn't work because probably have a typo somewhere. Public static void write diagnostics. Really? Now it works? Okay, fine. Be like that. Hopefully that means stuff is building again. Yeah, so the text span comparer should have a static accelerator. That is probably true, but as I said, I think what it will probably do in general is just instead of having separate types for that, you just make the text span itself comparable. That's interesting. So when I renamed mi.sh, I removed the flag. That is unfortunate. That is unfortunate. So then let's fix this first. So did the test pass? They did pass. So what have we done so far? So we've done a bunch of stuff. So we should probably now do this one here on the mi, which already exists. Right? And then we say commit amend. Well, what is the last commit? Yeah, that's great. So instead of doing that, let's say git commit fix Unix file flags. All right, so that one at least fixes this. So now let's think about the other side here. So when we say now mi, and maybe mi is not the best name because it conflicts with the PowerShell built-in commandlets. Well, here we have another issue that I need to fix at some point, but for now, our REPL keeps working, and if we say error, then we get error output that is colorized. So if we say error times 100, we only get error highlighted. Okay, so that's cool. So this stuff still works. And now the question is this one here, we just need a file path now. So I think the easiest way for us to do this is just go here and add a new file. Let's call this samples hello world.ms, right? Why not? For Minsk source. And then we say this is let name equals honestly don't know what our command is to actually, what is our built-in function for reading? Is it readline? No, I don't think so, right? Is it input? I think it's input. And then we say let me say hello plus name. Right, I think that seems right. So now we say Minsk compiler for samples hello world. Apparently we don't compile. Missing semicolon? Fine. Okay, that was not great. I see. I think I know what the problem is. The problem is in our batch file, we don't forward anything. So the way we forward in batch is, what is it, %*, which basically says everything you pass to the batch file, you also pass now to this project, which should fix this. Okay, I think I'm an idiot. Yep, okay, that works. Perfect. Now, the only thing is, we probably want, while we're here, let's say print what's your name? So that when we run it, we are not super surprised if nothing happens for a while. Yeah, now we can say that's my name, and great, awesome. And why not? All right. So the thing is, I don't know exactly how we do this in Bash. So let's just search Bash forwarding arguments. I think there is a, yeah, this looks familiar. Bum, bum, bum. What? What is it? Literally just this? I think that's what it is, right? Yeah. So it seems like this is literally what it is. All right. That means if you just go here in our shell script, that would be this. All right, so that seems reasonable. And now we say if result diagnostics any. Then we say console, I guess error, write diagnostics. I think we had this before, right? Result dot diagnostics syntax tree. All right. I'm still amazed that there's no suggesting namespace using for that. Okay, if result value is not null, then console out right line result.value. Also known as console.writeline. Let's just invert this for good measure. So we don't have any diagnostics, then we print the result. Otherwise, we write the diagnostics. All right, so that now means if we have a compiler error somewhere in this program here, let's say we have a semicolon here, which doesn't exist in our language. Yes, we should see the diagnostics. If we remove it, and we just have a raw number at the end, then it should print 42 at the end. Yep, all right, so that works the way we want to. Questions so far? So Brett says you want the quotes around it. I guess you mean in the bash file. So you mean probably in the batch file, right? Or do you mean because in the bash file we already have it. So here I don't have quotes, and you're saying I probably should have quotes here, if I read that correctly. All right, so that seems to work still, so I take that as a yes. All right, let's have a blank line here at the end as well. I think that is something that we can commit now. So git, not git diff, git status. What do we have? So we have, yeah, that's our text writer extensions first. For good measure, let's just say, actually no, screw it. We just commit the whole thing. Edit the project, and then of course edit this guy public, edit this extension method, great. So, all right, so now the thing we need to do still is, before we forget, we want plus execute on mc.sh. Add compiler project. Add sample and compiler project. All right, so now the question is, how do we support multiple files, right? So that's the real challenge that we want to go after. But before we do that, I think it's time that we make it easier for us to invoke this thing. So I showed this in the demo in the beginning, that when I'm in this file, I want to be able to just run this one file. So what we can do is we can go to our tasks here. And as you can see, we have a task called build, which just runs .NET against a particular, against our solution basically. And build is a built-in one, so if I can, what is it? I think it's Control-Shift-B, is that the one? Yeah. Basically now you select the task to run. And for some reason my Siri thinks... No, I do not want to talk to Siri. So what we can do here is we can do another task. We call this, not build, we call this MC. And we say this is, the type is, the command is .NET. It's an external process. The argument we pass is build. In our case, we pass run. And then we say this is our source mc.csproj. Then we pass in this argument, and now we pass in the actual file, which there is, I believe, some sort of special thing here. So the currently open file name, right? So that would be this guy. And then for problem watcher, we just go with ms compile for now. So if I now have this guy open, I should be able to just say yeah, why does this not? Oh, because it's build task. Yeah, I need to have a generic one, which is like, what is it? Run task. Yeah, so now I can select the MC task. If I hit enter, it will now not work because we configured it incorrectly. We have to say -- project here. And then we can say run task, MC. Oh, because it's the directory name that we passed in. Yeah, not the directory name, but the file base name file. All right, let's try this one more time. So now we would say run task, MC. And now we pass in the actual file name, and now we can see that we can run our program and it will terminate. And should we have any errors in here, if I say MC, it reports them, but we don't get any squiggles here. The reason we don't get any squiggles here is because this guy here, the problem watcher, basically what it does is there's either a built-in one, which in our case is pointed to ms compile, but there's also special ones where you can just, or like generic ones where you can say, use this regex to find errors on the command line. And so we just have to define what these are. And most importantly, as you can see, we don't print the file name right now. So it's not possible for us to know which file the error is actually about. So that's the first thing we need to fix, is basically print the file name, and also maybe print also not just the first character, but basically the range, right? From this line, from this character to this line to this character, right? So let's do that. So first let me add this one here and say, actually, there's also this other thing here, right? What is it called? Keyboard shortcuts. Can I search for it? Yeah, there is, I don't know, where does this go? View? There's some way to actually edit the keyboard shortcuts. That's a file on disk somewhere. What is that? Show user key bindings. Yeah, but how do I edit them? There is a file somewhere, is it not, that shows you the key bindings, like a JSON file. User settings, preferences, open user settings. Shortcut. Oh, what is it? Key. I'm blanking right now. If somebody knows, there is a way to do this, to actually open the JSON file. Point being is that I already have a registered shortcut that basically runs a particular task. And I don't remember where I set that. Yeah, that's funny. That is funny. VS Code user settings. I guess that works. See users. Mo app data. That would be probably roaming would be my guess. Code. User. bindings. That's the one I wanted, I think. Copy as path. God knows how I did this last time, but I'm pretty sure there was a command I could invoke to just navigate to that. Did I just lose the file name? Apparently, that is unfortunate. C users, ammo, app data, local, no, roaming, code, user, key bindings.json. Here we go. So I basically added this one binding here that says Control-Alt-M in my case, that just says run this task. And instead of saying MI, I say MC because that's what we actually named the task. So that means now if I'm in this file, all I have to do is Alt, Command, and M, and our task is running. Gee, that took longer than it should have. Add command to run compiler. I guess not command. Add task to run compiler. VS Code menu, file properties. Okay, now I'm clicked file. You need preferences probably, right? Yeah, this just opens this guy. File, preferences, settings. Is there a command here? Show user key bindings? Yeah, that just shows me the UI. But yeah. Anyway, so there's that. So where was I? So we now have our compiler project, but right now, again, the only thing we do is we just run this one file, which is not super useful. So we want to support multiple files. In order to do that, we need to first support multiple files in the diagnostic. So the one thing I want to change here is if we go to Minsk and we go to diagnostics, so right now a single diagnostic only has a span, right? And that's not very useful because that assumes, I mean, a span is literally just a start and a length, right? So what we really need is the file name, right? We need to know which file the stuff is in. So we can either add this to text span, but I really don't want to add this to text span because text spans are fairly heavily used in our syntax APIs, and so I want to keep these as small as possible. So what I really want to do is I want to have that information kind of on the diagnostic itself rather than on each syntax node, because the syntax node is of course always going to be in a single file for a given syntax tree. So I think what we want to do is we want to make sure that our syntax tree is associated with a source text, and a source text has a path, and then we come up with another abstraction here called, I don't know, text location, which is basically a span plus the source text. So let's do that first. So let's say we have a new public yeah, it doesn't really matter, public class. Let's go with a class for now, public sealed text location. That basically is a text, a source text and a text span. screw it, struct, good enough. Let me say this is a property that we want to initialize. This is a thing, and so just because I know we will need this, I say this is a start line, and that is the text get line index for span.start. End line is span.end, and then we say public int start character would be probably something like text lines for start line. So this is the start of the line. So this would be span.start minus the where the line started, and then I guess end character is the same thing. That would be span end minus this, right? So this seems somewhat right. So let's put this in its own file. Cool. So now the only thing is our source text currently does not have a file name. So we probably need that as well. So right now the only thing we have is the text string file name. So let's actually record this. Create initialize property file name. And then we say from text string file name. Let's start with an empty one by default if we don't have one. And then let's also have a convenience method and actually, yeah, let's make our lives easier because we already have that on the syntax tree, I think, anyway. So syntax tree, wherever you are, we have a parse one. So let's all make our lives a little bit easier, and I have a syntax tree API called load string file name, which we then say var text is file read all text for file name. And then we say var source text is source text from text comma file name, and then we say return parse source text. Right, this way each syntax tree has a source text, the source text has a path, and this way we can track the path. Now, the problem that we now have is that in the parser or the binder, we kind of don't have access to the syntax tree necessarily, right? So logically what we want right now is so that each expression syntax is a syntax node, each syntax node has a span, right? What we really want is we want another API called get location, which gives me the source text and the span in combination. But the syntax node doesn't know which tree it is in, right? Because the way we construct things right now, if you go to our syntax tree API, if I find it here again, we run the parser in the constructor here, and then the parser just constructs a bunch of nodes, and then we just get the compilation unit syntax, which is the root node, and we just assign that. So, but what we can do, we can cheat a little bit, and we can say, given that we're here in the constructor, we can basically give the parser ourselves which allows us now to basically initialize each syntax node with the syntax tree it's contained in, which is quite convenient. So let's do that first. So let's add this guy here. So now we have a syntax tree which we so the syntax tree itself. So the one thing we want to do probably is assign the text, because later phases might actually access the text. And then parse just ourselves rather than the syntax text as well. And then same here. The lexer gets the syntax tree. Syntax tree. Syntax tree. And then we say this is syntax tree.text. And then we also record this guy. All right, so then these guys are in there. I'm not entirely sure why I guess, who's using text right now? Quite a few actually. All right, so that makes all sense. Except where this guy just says no, the parser also has a text field apparently. So let's assign the syntax tree as well. Syntax tree equals syntax tree. All right. This should get us to compile again. And then syntax tree, what's the problem here? I see. So the reason we pass this in ultimately is so that when we construct tokens and nodes, so that we can parse in the syntax tree they're contained in. But then, of course, I also support parsing individual nodes right now. Sorry, individual tokens, which you have to think about how we want to do this. I think the way we will do this is we will pass in a delegate that does the parsing. If that makes sense. So realistically, what we need to return is, so we need a delegate, private delegate, parse handler, and the parse handler gets the syntax tree. And what does it has to give us back? I think it has to give us back the compilation unit syntax root, and it has to give us back an immutable array of diagnostics. Right? That seems about right. And then we can say, okay, we want a parse handler here. and then we can say parse handler. So pass in this out var root out var diagnostics. Right. And then we basically only need private static void parse, which takes a syntax tree out, compilation root out immutable array diagnostics. Right, let's put this somewhere here. And realistically, that's what it is. Right, and then in this case, maybe we would say lex me the tokens. We would not do that. We would have a different handler here where we would say, what is that? It would say void parse tokens. It would get the syntax tree. Out compilation units in the root, and we would say out immutable array diagnostics. Right. And then basically we would just go over these guys. Syntax tree. We would say lex. We would say we have var tokens is new list of syntax token, and we would just say this is tokens add token, right? And then we would say root equals new compilation unit syntax root for immutable array of what is this guy? Member syntax, okay, of member syntax empty, and we would say end of file token. Okay, fine. Now let's do it the other way around. Token. Yeah, and break, of course. And then we can just say diagnostics that we return is just the Lexus diagnostics to immutable array. right? And so now we can just say var syntax tree new syntax tree for the text that we passed in and parse tokens. And then I can just say return tokens to immutable array. So this looks a little bit convoluted, but it's kind of, the idea here is that, can probably just do that. Because the idea here is that effectively all the parsing has to happen from the constructor of the syntax tree so that everything always is properly initialized. All right, so now this is fine. Now the only thing we need to change now is we need to say each syntax token, the first argument that it gets is syntax tree. In fact, each syntax node has a protected constructor, syntax node. Syntax node, syntax tree gets its syntax tree. And now we have a lot of stuff that is no longer compiling, but that's fine. And so each syntax token now has to say base syntax tree. And then that now means in the lexer, each time we construct a token, we have to say the syntax tree that we pass in, so that's fine. And now, of course, every single node now needs base syntax tree. No semicolon. Now let's do this pair. Lazy copy and paste. Yeah, these are the moments where you wish you would have not written the parser by hand, but hey. We have so much more control with this. That is not even funny. All right, so syntax tree, syntax tree. Syntax tree, syntax tree. Syntax tree, syntax tree. Syntax tree, syntax tree. Oopsie. Yeah, this guy needs a constructor. That was easy. That one doesn't need anything. This one needs a syntax tree, and it needs the constructor. Same thing here, it needs the syntax tree and the constructor. Syntax tree, and this guy. This guy needs a syntax tree that it has to forward, and then this guy has a syntax tree that it has to put to base. All right, so this Y needs a syntax tree as well. Syntax tree. Almost there. Syntax tree, syntax tree. I am getting mildly annoyed by doing all of this. But on the other hand, it's sometimes nice to do something repetitive because it means your brain can pretty much entirely disengage and then everything is good. So, now we're literally almost done. Nice. So the only thing now we have to now fix is, of course, the syntax tree here. What is wrong here? Oh yeah, we have to pass in now the syntax tree that we got from there. And then here, same thing. So every time now we construct a node, we need to tell it which syntax tree that is, which is now easy because we have it. So not a biggie, just a lot of copy paste. Right? So this is a lot of busy work, but trust me, this is really worthwhile because if each node knows its syntax tree, you can do interesting things. So for example, we can also now, remember that the whole syntax tree is immutable? Yeah, that makes it hard to know the parent, but given that each node now knows its syntax tree, we can lazily construct a dictionary on the syntax tree that knows for each node who the parent node is, which will later allow us to say, we can basically pretend that every syntax node knows its parent. And then certain things are much easier to do. Like for example, you can ask for a location and then reverse look up the node that contains that location. Powerful stuff. Yeah, that is a good one. All right, so there were a few comments on the way I did the parser. No, actually the way I did the syntax tree. So yeah, this should be a static function that is, yeah, so it can't be a static function because the side effect of us parsing the tokens is that we want to get this token list. So to make this a static function, I have no way to return the tokens right now. So this one cannot be a static function. This one literally has to have access to this token list. Yeah, somebody says instead of doing two outs, we could just have basically just return the root in the diagnostic as a tuple. We could. I'm not sure that helps readability. I personally find tuples are useful when the return values are kind of like obvious, I guess. Like when you, for example, when I don't know, parse position and you return a start and a length maybe, but for these arbitrary things, I'm not sure that's helping readability, in all honesty. And then, end line as index. Start line, end line. That looks right for now, so let's just see what happens. So, okay, now we have that thing, but now what we don't have is the get location API. So first, let's add this API here. Let's call this public text location. Location, and we just say location is new text location for span and, of course, for the syntax tree text and span. Okay, cool, we have that. Now, of course, we don't use it yet, so our diagnostic, instead of taking a span, should take a text location, a location. You know what? Let's not do that. That seems over the top. All right, so now our diagnostic back no longer works because this is where we construct all the error messages. So of course now report needs to take a location, text location, and we pass that guy in. And now we get a lot more errors. So how about we take all of those guys, and we say this, and we say text location, a location. And then we say, every time we say this, we now say this. All right, that fixes almost all the errors, except for a few cases. So report bad character. So let's just get a text location here as well and move that logic where we compute that whoever calls us, which is probably going to be the Lexer, would be my guess. Yes, so when this would be here. So we would say span would be new text span for position. The length would be 1. The location would be new text location for the text and the span. And then we would just report that. And then what happens here, report unterminated string. Yes, that would also be a location, would be new text location for text and span. And then we say location. Okay, so we call this span, var span, and then we say location is new text location for the text and the span, and then we report that. All right, and then in the parser, what's happening here? Apparently there's a bug right here. Unexpected token, current location. All right, so far so good. So now the syntax is working. Now binder. So the binder also reports errors, and of course the binder reports them currently on span. So all we have to do now is change location. Let's change span to location. So that would be easy. And yes, there are more sophisticated refactoring ways that would avoid me having to type all of this, but I agree with Frank Kruger, who recently said on his stream that Sometimes when you do renames or shuffling things around, it actually helps if you go over all the call sites, because you never know. Okay, this one seems to be more involved. Same here, same here. So diagnostic span, okay, let's take and get this diagnostic location. Location. Bind variable reference, that would be a text location. Location. Really? I mean, isn't that always called with an identifier? Yeah. So how about we do this? We pass in the identifier token instead. Seems a bit weird to pass them as separate. And we call this syntax token, identifier token. And then we can say this is this guy. We can say var name equals text. Sorry, name. And then we can just say report undefined variable for identifier token location. All right. So now this guy, of course, passes this guy. Okay, that was already fixed. So what is happening here? We say probably syntax.location. So what's happening here? Expression.location. Expression.location. And initializer location. All right, so now the only one that is problematic is this one here, where we construct a span somehow. Okay, we can say location is new text location for what? I guess you can say syntax. Syntax tree text and the span, and then we just say location, right? That seems right. All right. Writing diagnostics. Now we have to say d.location.span. And we probably want to start by file name. So we should probably say then by order by d.location file name. Sure, that works. And then we just say, sweet. Yeah, now I think it's time for us to also fix the error output for multiple lines. And then I think we're almost there. How much are we time-wise? Yeah, we're good in time too, so that's all good. So basically, what this is supposed to do, if you read between the lines, no pun intended, is that we try to print some contextual stuff here, right? So we basically try to get the line index, and then we, basically we try to find the line the error is on, right? And we assume it's a single line. So instead of doing that, Yeah, I guess. Yeah, let's just fix the stuff right now and then just deal with the fallout later. So let's just say span is diagnostic location span. Let's just call it span. Good enough for now. I just want to get to the point where stuff compiles again. All right. Lecture test. So that would be location.span. Okay. An evaluation test, same thing. This would be diagnostic location span. Okay. Now let's see how we did. What's happening here? This operation cannot be performed on a default instance of a immutable array. What? Lexa unterminated string in line 22. I guess parse tokens returns the default instance of immutable array. How the fuck is that possible? I mean, break will break the loop, sure, but then L diagnostics to immutable array should. I mean, clearly this thing is always set to something. Diagnostics, diagnostic bank. Yeah, this one always has a diagnostic. Why would that not work? I am very confused by that. Can I repro this in the interactive mode? Well, no, I cannot. So it must be this API here then, where we say parse tokens, where weird stuff is happening. So we call parse tokens. Oh, I'm an idiot. Yes, 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 yes. We also have to say diagnostics is, okay, so let's do same naming here. Syntax tree is this guy, and then diagnostics is syntax tree diagnostics to immutable array. I'm very confused that this is even compiling. Why does this compile? I never assigned diagnostics. It's an out variable. Why would that not compile? Like, why would that compile? Like, if I remove this line, there should be an error message that says, you didn't assign diagnostics. I'm very confused by this. Maybe I'm slow this morning, but like that seems... Isn't that how determinate assignment works in C#? Yeah, you don't have to assign the variable because syntax tree normally wasn't necessary. It just relies on the side effect of running the constructor. I mean, that's not pretty, but that's what it is. Okay, now it works, but like that, I'm very confused by this. So what's basically happening here is that the diagnostics are effectively tracked through the syntax tree, right? And when we return we need to return the diagnostics from the outer function as well, and we didn't do that. But this, if I comment this out, this shouldn't have compiled. I'm pretty certain. All right. Anyway, so now we have that. Now let's actually, in this guy here, also let's print the file number. So right now we don't only print the line number and the character. So how does C# do that? So if I do this, what's the error message going to be? So C# basically prints the file name followed by a parenthesis. All right, let's do the same thing then. Let's say this would be file name equals diagnostics location, diagnostic location text file name, right? Now this is one where it probably makes sense to lift this up a little bit. To say this is this one here, it just feels a little bit redundant to do that. And now when we say when we run interactive, it shouldn't have changed because interactive never sets a file name. What is happening? Oh. No. What? Text location. Did I not? Oh. All right, so again, let's find out what's happening. So if we now say something like this, we just have an empty string here, so that's fine. If I now go into my favorite file here, hello world, and we just add a semicolon, and we then do, what is it? Command Alt M, or Control Alt M, then it does not print the file name. It does not print the file name. Why not? Why not? Oh, because, yes, because the way we construct it right now in our compiler, we do this thing by hand. So instead of doing syntax_tree.parse, we should say syntax_tree.load, because then it takes care of setting the path as well. Well, let's be nice and say if the file does not exist, then say error file. it doesn't exist, right? All right, let's try this. Haha! Now we have that, and if I click on this, nothing happens. Is it a bug in VS Code or is that a bug in my thing? I mean, 219. I mean, clearly that exists, right? Line 219. If I close this, if I close all of those, does this actually do anything? Oh, you have to control click on it. Okay, so now it works. So it just jumps right here. So if I'm setting my cursor here and I do control click, it jumps right where the error is. Convenient. All right, so this is halfway where we want to be, but we still don't see squiggles. So the reason we don't see squiggles is the way we report errors here is not in a way where, like even here, see under problems, you don't see any problems. So in order for us to make that work, we have to change in our tasks here. We have to actually set a problem matcher. So, and now I can say a bunch of stuff here. So I can do pattern, apply to background base. So this is one of those areas where I do not remember how to do any of this. Visual Studio Code, problem matcher. And hopefully that is here. No. Here, that's where it's at. Problem matcher, defining a problem matcher. So here's an example of one. Where basically say file location. All right, so let's say file location. We would say that's absolute because that's how we report it. File location, pattern. I see, so pattern. All right, so this is an example where it gives me a regex, and then it says, effectively the first group is the file name, the second group is the location, the third group is the message. So that might actually work for us already. So let's see whether this, let's see whether anything else we need to set. Don't think so. So let's see what happens if I do this now. Well, in this case it actually works now, so that would be lame. Let's choose a function that doesn't actually exist. And let's try this again. We don't get anything back. That is unfortunate. I think this might be because we have a space there. Let's see whether the space, I think the space fixes anything. No, unfortunately not. Maybe we need to change our regex a little bit. How about we just write our regex by hand? So we basically say everything except for a closing brace. Yeah, that's also not how we want to do this, right? So this is a everything except for an opening brace. Actually, let's just do this. Something in parentheses. Yeah, think I need 4 because I have to double escape for JSON and for regex, which is amazing to read. And then a colon, optional spaces, and then a bunch of other stuff that is the, yeah, we need, of course, parentheses here in order to find the stuff between the parentheses. One, two, three, something like that. Does that help? There's one of these more finicky ones. Oh, I'm an idiot. I'm adding this to the wrong thing. That also might be why nothing works. All right, let's actually add this to the right one this time. Okay, so now I'm actually inclined to copy and paste this guy out again and then just see what the default was. This is the nice thing with VS Code, that it's very extensible and you can just use regex. What's not so nice is when stuff doesn't work, you often don't know why. How about I cheat? Because I already have that working and nobody wants to see me hunt things. Like this. So let's just do Git show episode 15 prep. So there is a part where I have that configured. So I know this one works. Well, for some definition of works. Let's get the braces lined up. All right. Let's try this one more time. That is funny. Do I have to close VS Code every single time I do this? No. That would be weird, right? I mean, just for good measure, let's just copy the whole section here and see whether that changes anything. I don't think it does though. Maybe. Boom, boom, boom. So we say type is shell. Maybe that changes something. Echo, reveal, focus, panel. Okay, so let's see. Oh yeah, I also renamed it now, which is not good. Oh yeah, I also changed it to pass in the role path, the directory name. So let's do the file for now. Yeah, maybe it really doesn't like my... Oh, because this is also... Okay. Now I'm at the point where let's just change the output as well. So, where is this guy? Diagnostics, text writer extension. So, instead of saying line number character, let's actually do var start line is diagnostic location start line +1, right? Because their visual output is 1 based. End line start character, that is start character, and then this is end character is location end character. So we don't need any of those, and we just say this is start character, comma, end line, comma, end character. Well, let's see what we get. Maybe that also helps. Yes, now we have at least output. So I guess I did forget a +1 somewhere, right? Yes, this would be a +1 and this would be a +1. So, and then we should have print underlined correctly. Here we go. Now we have this squiggle, and if we hover over print, it says the error message print doesn't exist. So that is very close to what a decent experience is like. And if we fix this one and we just rerun it, it disappears, hopefully. Yeah, it just runs now. And once it's done, it's done. And if I say try to assign to name again, we should get an error message as well that we can't assign to name. And that should also show up under problems. Here we go, problems, which we also get now from this output matcher. So we have them all in a very nice output. All right, so that's not too bad, not too shabby. Now, let me commit this. Oh yeah, I see now what the problem is. What is this? I want this window here. All right. All right, so this is basically all the work we have done, so just so we can track nodes in a better fashion. But this is what you're going to do. I mean, half of what a good compiler is just diagnostics. Being able to report errors where they occur is critical. Yeah, we have done quite a bit today. Okay, here's all the syntax nodes where we added the constructor parameter. Here's the Lexer work we've done. All right. Here's the parser work where we pass the syntax tree to the nodes. Here's more syntax nodes. Yeah, that's the location API. That's the syntax tree itself. More constructor parsing. The new location one. The ordering stuff. Nice. All right. Add file path to add file information to syntax node. That is a lot of stuff for small things. All right, so let me push this. Whoops, no, not that. Let's run this. All right, so now the squiggle would disappear. Nice. All right, so now we have that. So the only thing that we still don't do is we don't have support for multiple compilations, right? So that is something we need to do as well. So right now when we go to our compilation, we only have a single syntax tree, right? Which is not super useful, right? We technically want to have support for multiple, which isn't that hard. You just have to think about that. Let me just quickly look at the time. Yeah, I'm slightly over time. So let me just think about what work would be required to pull that off. It wouldn't be much. It would just be a few more for loops, I think. So if we just go to compilation here, let's say we take a params syntax tree, which makes it a little bit more nice, and then we can say the same thing here, and then we can say syntax trees would be syntax trees to immutable array. Oh god, no. Oh my god, what have I done? Don't save. Oh my god. File. Alright, what's the easiest way to undo this? Can I just not close all? There's only save all. Alright, fine then. Alright, so we have that. Let's go back. What is that? File close all. There's no close all. Close all. Here we go. Compilation. Params syntax tree. What I really want to rename was this guy. And then we just say syntax trees is to immutable array. And then we say syntax trees, and this is an immutable array. of syntax tree, right? Yeah, that wouldn't be terribly complicated. Yeah, probably we don't want the params here, we probably want the params here. Nah. Apparently we also want it here. All right. So bind global scope. Instead of saying this, let's say immutable array, syntax tree, syntax trees. Function declarations, that would be syntax trees, select many, st root members of type right, something like this. And then we can say, same thing here, we can say global statements. That would be kind of similar, except this. Okay, this fixes the binder, I think. And instead of saying this, we say syntax trees. All right, so that fixes that. So all the diagnostics are effectively, okay, let's say parse diagnostics. Diagnostics would be syntax trees, select many, st diagnostics. And then we say all the diagnostics are parse diagnostics plus global diagnostics to immutable array. All right, let's see whether this builds. Oh, it won't. Actually, it will build, yeah. Holy cannoli, it does compile. So now let's go back to the compiler here, and where we have this restriction here, we remove that restriction. We say paths is args, and then we say var syntax trees is new list of syntax tree, and then of course we say paths.length because why not. And then we say for each var path in paths, and then we just say paths, sorry, we'd say it in here, and then we say syntax trees add syntax tree, of course. And then we just say syntax trees to array, right? Oh yeah, and we can totally remove this one here because that is just lame. Var syntax tree is diagnostic location. Actually, you don't need the syntax tree at all. Like, where do you need the syntax tree? Where do you think you need the syntax tree? What you need is the text. Text is diagnostic location text. Right? So instead of doing this, we say something like var has errors, false, and then we say has errors, true. Continue. And then we say if has errors, return. Yes, so let's extract this into a function. Let's say get paths for args, get file paths. Let me say this is returning a string, enumerable of string, let's say. And let's say it takes an enumerable of string. For each var path in args, let's say paths, if directory exists for path, yeah, let's say result is a new sorted set of string. So what would be nice if we would support directories, basically. So if this is a directory, then we say result, I guess result, what is it, union with, and then we say directory, enumerate files in the path. Search pattern would be star.ms because that's the extension, and we say enumeration options, sorry, what is this thing called? Enumeration options, right? Yeah, search option, all directories, okay? Else, result, add, path. Seems reasonable. And then we say return result. So we don't validate files. Maybe we should. I guess that's more work than we want. See, don't be too smart. Right, so this should still work. Of course, we can remove this guy here now. Let's actually make this one commit. What is that? So this one we should add. This one she should add. And then this one we should add. And call this remove syntax tree parameter. All right, so that's this build. this should build as well. And then the nice thing with this one now is it allows us also to launch programs rather than just individual files. Okay, this works. So now if we go to our sample here and we run this guy, that should also still do the right thing. All right, that's inconvenient. So that one works. So let me add one more file here. Let's call this getName ms. And let's do something completely over-engineered. And let's have a function here. Function getName, which returns a string. And basically what it does is it just says print, and then says name, and then say return name, right? And then over here, instead of doing this, we say get name. So now we have basically a program that consists of two files. In order for us to launch that, we just slightly change this guy here, and instead of passing in the file, we say file directory name. So we basically pass in the whole directory, and since we expand directories now, I should be able to go on any of these files and just say do this, and stuff just works, or not for that matter. So what we do here is, why would that fail? Run project p Minsk symbols hello. Where does this parenthesis come from? Oh, because I have an extra parenthesis here. That makes sense. All right, so let's do that. And then, no, it should work. Or not? What is happening here? Yeah, okay, so now it does work. Sweet! So now we have, and of course if I now make typos in here, right, use a function that doesn't exist, and I compile, now we hopefully get an error message for that file, as you would expect. We do, but for some reason the problem manager no longer works, which is very weird. I mean, clearly, I guess 416 to 420. I mean, it's the correct range. I have to say, this is the downside with regex, which is very, very inconvenient. Okay, this works, so I have no idea why it doesn't work for other files, but that is for another day. That is for another day. So this works, good enough. So let's add this one. Da-dum, da-dum. And we call this add support for multiple files. Sweet, sweet, sweet. All right, this is all I have for today. It took longer than I was hoping for, but at least we achieved what we wanted to achieve. So next week what I want to do is I want to take this up a little bit and just relax a little bit and fix our REPL a little bit. Because right now our REPL is a super useful debugging tool, and I would like to extend this a little bit with more meta commands. So we can, when we have multiple functions, we can actually dump specific functions, look what the compilation status of those functions ends up being, and this will make it easier for us to then, the episode after, I want to normalize the way we lower our, basically, right now we have this magic mode where when you have global statements, they're just somehow interpreted, but what I really want to do is I want to put them into functions. So basically the idea is if you have a global function, if you have global statements, they get rewritten into the main method, and so they have the main function, and those become the body of the main function. And so once we have that, we have uniformity between what we would put into a console app where we actually have a main function, and in a script where you basically only have global statements, if you will. And so after we have done this, so this basically means next week fixing the REPL, the week after lowering to make these things uniform, I think then I'm ready to finally start emitting IL. And I think once we have IL done, I will add debugging support for that as well. So it probably takes us 3-4 weeks where we actually do the heavy lifting, and then we can actually go into a little bit more detail. And so before I now wrap up, let me just go over the questions really quick, because I was very much in my zone. I did not pay much attention to what was happening in the chat. If you find yourself unable to stream regularly, would you consider publishing the version of the compiler you demoed in episode 1? Yes. However, I think I will get to a point where we have most of the stuff that I demoed in episode 1. Isn't this wrong? Start line public int end character is span end minus text line start. Okay, let's take a look at this really quick. Text, I guess it's in text location. So start line. Yes, that is wrong. So that should be end line. You are totally correct. Fix reference of start line to end line. Awesome. So everybody seems to be happy. So next week, same location, 8 a.m. and probably exactly 2 hours, not longer than today, because next one will be more easy. And then, yeah, hope you enjoyed this. And then if you have any feedback, let me know in the comments. Bye-bye.